In our last episode, we learned about enthalpy, which is a thermodynamic quantity equivalent to the total heat content of a system. And we increased the heat content of our backyard furnace and melted down aluminum with a melting temperature of around 630 degrees Celsius. Today, in part 2, we're moving on to copper, which we'll discuss in more detail as we move forward. However, before we move on, we need to discuss and answer the question of what is the difference between heat and temperature? Actually, we're going to go ahead and answer that at the end of this video. We're going to jump right into the second use of our backyard furnace. So right away, we wanted to make new molds for our casting. We needed updated molds, so we have some clay and we cut it out into some shapes that we liked. We used plaster. We put it in plaster molds. Once the molds dry out, we take it out of the plaster. It's not that hard, but it takes a little bit of time. Here we are. We scrape it out. We'll actually hold on to that clay because that clay is reusable. We've had it for several years and it keeps being useful. So there we are. And we have 3 different molds. We have a gear, we have a knight piece from a chess set, and we have a vial. Here we are. We have some copper that we got, and we're just cutting it up. And we'll learn later that this wasn't the best way to do it, perhaps. We're creating more surface area where heat will escape. But there we have copper. The melting point is 1084 degrees Celsius. And our furnace is ready to go. We've cleaned it up. We've got it prepped. Put some wood in there just to get it started. Make sure we have fire going. You can't really see it sometimes, so we like to put some wood in there and we just burn it down just to get it going. Make sure we got a flame. Here it is. You can see the propane being sent into the furnace, and it slows down. You can see it burning blue. That blue color is good. That means a full combustion, which is really good. We actually should probably increase the amount of oxygen. We might redesign our furnace for that. There's some pictures looking in. You can see it's getting hot. The crucible's turning red. We couldn't get the temperature high enough, so here we are putting in the aluminum. We kind of thought it might act as a lid to increase the pressure or the density, and sure enough, once we got the aluminum in there, the copper actually started to melt. So we have a mixture, an alloy of aluminum and copper. And again, after waiting for a very long time, all of a sudden you have to pour it, and we're trying to stay calm, but it's really hard and you don't have a good grip. Here she goes pouring it. And the mix is called aluminum bronze. It's not like bronze that they use to make a bell, which uses tin, but this is aluminum bronze. And what we'll come to find out is we put way too much aluminum in this. And so the alloy is very brittle. And we'll see that. There's some slag on top. I'm going to clean it up. She's going to shake it out. It's already re-solidified. So the temperature dropped really quickly. And we're going to move on. There's the empty crucible, cleaned out pretty nicely. And we're gonna drift over to the view. There's our furnace. It's still looking pretty good, but over here in the corner, our lid totally cracked up. So we'll have to remake a lid or suffer from it decreased.
Alright, so here we go. They've cooled off in the mold just a bit. So oh wow, you came out. It's really easy. Move on, let's go to the next one. Ooh, it's got this really cool crystal, pretty glistening color. You can probably hold the mold with your hand if you need it. It's gonna break. Alright, that's fine. Oh, that's nice. Okay, go, get this. snowman. Oh, your head, snowman. Oh! In times like these, that's what you don't want to do.
So here's the finished product. The pores didn't go very well, as you can see, and the aluminum bronze is very weak. The front edge of the knight is actually broken off already, and there's a bubble in it. Let's see. You can see where it broke off. It's very brittle. As you get closer, you can see it looks like a crackle chocolate candy bar. But moving forward, this was very fun. Our furnace is wearing out. We probably have one more opportunity to melt something down. So we'll probably melt this down and maybe try and re-pour it or add more copper perhaps and change the percentages. But we had a lot of fun with this. It's the first time we've ever successfully melted copper, even though we ended up having to alloy it with aluminum, which made it very weak. It was still very fun. We learned a lot. Now we're going to go ahead and get back to understanding the difference between heat and temperature. Much like the difference between mass and weight, they are sometimes used interchangeably, but they have very different meanings and definitions. So let's begin with heat. Heat is a description of energy in motion between multiple systems. For example, the heat of the furnace transferring into the metal in the crucible, or our chemically active bodies transferring heat into the cold environment around us. A more formal definition begins by talking about matter. Matter is made up of atoms and molecules, and energy causes the atoms and molecules to always be in motion, either bumping into each other or vibrating back and forth. The motion of atoms and molecules creates a form of energy called heat, or thermal energy, which is present in all matter. Even in the coldest voids of space, matter still has a very small but still measurable amount of heat energy. Energy can take many forms and can change from one form to another. Many different types of energy can be converted into heat energy. Light, electrical, mechanical, chemical, nuclear, sound, and thermal energy itself can each cause a substance to heat up by increasing the speed of its molecules. So put energy into a system and it heats up. Take energy away and it cools. Temperature. Temperature is a description of the total heat in a single system. Temperature is a measure of the average heat or thermal energy of the particles in a system. Since it is an average measurement, it does not depend on the number of particles in an object. In that sense, it does not depend on the size of it. For example, the temperature of a small cup of boiling water is the same as the temperature of a large pot of boiling water, even if the large pot is much bigger than the cup and has millions and millions more water molecules. The relationship between heat and temperature is formally known as the study of thermodynamics. The term thermodynamics can be dissected to understand more clearly. Thermo comes from the Greek for heat, and dynamics can be defined as active or in motion. So thermodynamics is the study of heat in motion. Thus, in part 2 of Enthalpy with a furnace, we will be seeking to transfer heat into the system of scrap metal piled in the crucible in order to raise the metal's temperature to its melting point, which for copper is roughly 1084 degrees Celsius. Copper is a chemical element with the symbol Cu from the Latin cuprum, an atomic number of 29. It is a soft, malleable, and ductile metal with very high thermal and electrical conductivity. copper is used as a conductor of heat and electricity, as a building material, and as a constituent of various metal alloys such as bronze.